Have you ever taken a walk through a forest and really truly wondered what's underneath your feet? And I don't just mean the dirt and roots. I mean the deep, deep history locked away in the rock itself. Well, today we're going to uncover the story of one specific forest. A story that spans an incredible 425 million years, involves continents smashing into each other, and mountains that were once as tall as the Alps.
So take a look at this. It looks so peaceful, doesn't it? You've got rolling hills, thick woods. It's a classic, beautiful European landscape. You'd think it's been this way forever, stable, permanent. But the story this place has to tell is actually one of unimaginable geological violence and constant radical change.
So let's ask the really big question. If we could hop in a time machine and just rewind, and I mean way back, before the dinosaurs, before the very first complex life even crawled out onto land, what would we find right in this exact spot? The answer is probably not what you're expecting. That's right, an ocean floor. Not a forest in Germany, not even Europe as we know it. We would be at the bottom of a huge ancient ocean, and we'd be just a little south of the equator. So forget the rolling hills, this was a totally alien aquatic world. Okay, so our story kicks off way back in the Silurian period, a time when a map of the Earth would look completely unrecognizable to us today. Just look at this ancient map. The whole arrangement of the continents is just different. You've got Laurentia over here, which would eventually become North America, and Baltica, the future Scandinavia. And sitting between them and that massive southern continent, Gondwana, is the Rheic Ocean. And our spot, that future forest, it's right there, sitting quietly at the bottom of that ancient sea. But life on the quiet ocean floor wasn't going to stay quiet for very long. The Earth's tectonic plates were on the move. And the next chapter of our story is just pure geological chaos. As we roll into the Devonian period, these huge land masses started crashing into each other. Now, this isn't like a car crash. This is a collision happening in ultra-slow motion over millions and millions of years. It's this unstoppable force that's just squeezing that ocean that once separated them completely shut. And it all boils down to one key concept: subduction. As the continents push together, the heavier oceanic crust, the floor of the Rheic Ocean, gets forced to dive down underneath the lighter continental plates. It sinks back into the Earth's mantle and melts. Trust me, this is not a gentle process. It is absolutely a world-shaping one. And you can see exactly how it played out right here. On the left, you've got the calm, happy ocean floor. But as subduction kicks into high gear on the right, just look at that result. The melting plate fuels a whole chain of volcanoes, and that immense pressure starts to crumple and lift the crust itself. It's a total transformation. This collision didn't just create a few hills. No way. It forged a massive mountain range, a jagged chain of volcanoes and rock that stretched all the way across the newly formed supercontinent. These things were giants, rivaling today's Alps in sheer scale and majesty. Just try to picture that. All right, now we have to take a huge leap forward in time. Those mountains, they had their moment of glory, but as we know, pretty much nothing on Earth lasts forever. So we're jumping from the Devonian, skipping right past the Carboniferous, the Permian, the Triassic, and the Jurassic, all the way to the Cretaceous. We're talking about more than 200 million years of wind and rain and ice, just slowly, relentlessly grinding those colossal mountains down to absolutely nothing. By the time the dinosaurs were having their moment, the landscape had transformed yet again. The mountains were gone, worn down flat to their very roots. The land itself actually sank, and a warm, shallow, tropical sea flooded the entire region, covering most of what we now call Northern Europe. And for millions of years in this calm sea, a very slow, very patient process was underway. Think of it like a gentle, constant snow, but made of the shells and skeletons of countless tiny marine creatures. They rained down on the seafloor, creating these thick layers of chalky sediment that would eventually harden into limestone. At the same time, rivers were washing sand off the remaining land, and that sand settled in its own layers, which would one day become sandstone. So now we've got these nice flat layers of limestone and sandstone just sitting on top of the eroded stumps of those ancient mountains. But the story is not over, not even close. Another huge geological drama was about to unfold, and its epicenter was far, far to the south. Hundreds of miles away, a whole new collision was beginning. The African plate started its slow, powerful push north right into the European plate. And this is a big one. It's the very same collision that is still building the Alps today. Now, you might be thinking, a collision that far south? Why would that matter up here? Well, the Earth's crust isn't perfectly rigid. The incredible pressure from the Alps being born rippled outwards, like a shock wave traveling through solid rock. And around 70 million years ago, that pressure wave finally reached the quiet, flat seabed of what would become northern Germany. Here's a great way to picture it. Imagine pushing a big rug against a wall. It doesn't stay flat, right? It buckles up and folds. That is exactly what happened to those neat, flat layers of limestone and sandstone. The immense pressure squeezed them, tilting them and folding them up into a whole series of ridges. So the basic structure is in place now, folded layers of rock still hidden underneath the sea. All that's left is the final act, sculpting the landscape that we can actually go and see today. So how did it all come together in the end? Well, first, the whole region began to lift up out of the sea. Then, for the last 5 million years or so, erosion took over. But this time, it wasn't just grinding down a uniform mountain range. It was carving into those folded layers of rock, and it was washing away the softer limestone, leaving the tougher, more resistant sandstone standing tall as ridges. And here is the final result. The hills of the Teutoburg forest aren't random at all. They are the exposed edges of those ancient sandstone beds, the ones that were tilted and folded by that echo from the Alps. When you see formations like the famous Duranther Klippen, you are looking at direct, visible evidence of this incredible, deep history. I mean, just think about that journey for a second. From a deep ocean floor south of the equator to mountains as high as the Alps. Then it was completely erased, submerged under a tropical sea, squeezed and folded by a continental collision hundreds of miles away, and finally sculpted by erosion into the forest we see today. It's just incredible. The Teutoburger forest is just this powerful reminder that the ground beneath us is never static. It's a library of deep time filled with these epic stories of lost oceans and phantom mountains. And it really makes you wonder, doesn't it? What incredible story is waiting to be read in the landscape right outside your own window?